नाउ अभी चेक कर लो, अभी चेक कर लो। नाउ एम ऑडिबल ना हुई है, अभी बोलिए, एम ऑडिबल नाउ? यस फाइन, चलिए आज का सेशन हम शुरू करेगा। यू कैन सी ना हुई है। सो अभी हमने डिस्कस करने वाला है बढ़िया से बढ़िया ऑफर्स चल रहा अभी अनअकैडमी में। द ब्रह्मास्त्र बैच शुरू होने वाला, दैट इज फ्रॉम जुलाई 31 से होने वाला। यू कैन सी ना हुई है। आदित्य सर ने शुरू करने वाला, सो कंट्रोल सिस्टम्स आई एम गोइंग टू स्टार्ट विद द सिग्नल सिस्टम शुरू होने वाला, दैट इज 6:30 PM। राइट, फॉर गेट एंड ESC एकलव्य बैच पर 2027 के लिए। एंड हमने शुरू किया इसरो बैच भी हमने शुरू किया। यू कैन सी दिस थिंग, इसरो बैच का सब्सक्रिप्शन दिस इज 3,999 ओनली। राइट, एंड नक्षत्र बैच भी शुरू हुआ। इन दिस वी आर स्टार्टिंग दिस एज नेटवर्क्स एंड द मटेरियल साइंस हो रहा अभी। And the test series which is live from April 1st onwards, you can get the test series. Topic wise test series 29, subject wise 10, advanced subject 10, multi subject 6 and full length mock test and 12 years of PYQ भी test series आपको मिलेगा। And totally how many test series you can attempt now here? 77. Right. So we do offering the two subscriptions. One is a plus as well as iconic. Plus में आपको क्या चीज मिलेगा? टॉप एडिकेटर्स क्लासेस मिलेगा, लाइव डाउट, स्ट्रक्चर्ड कोर्सेस, PDF, quizzes, unlimited access. You can access, so you can watch the class any number of time. There is no restriction. एंड आइकॉनिक में क्या एक्स्ट्रा मिलेगा आपको? पर्सनल कोच भी मिलेगा। विद दिस द पर्सनल मेंटर विल बी असाइन्ड टू यू and you can directly interact with this your mentor, and whatever the doubts, the preparation strategy and all, you can able to discuss with your mentor. And what we can do here, simply book the slot according to your time convenience and time slot, how much duration, and directly connect with your mentor. You can plan the serious subscription with the Unacademy to have a great learning experience. Right. So these are the GATE 2025 ka rankers from Unacademy. So you can start the serious preparation. So here from 31st से नया batch शुरू होने वाला, that is a last live batch. And so try to join those things. We have only 6 months is left. With the 6 months you can able to definitely able to crack it, and with the proper guidance and proper preparations. ठीक है, चलो। Right, now look at, now first of all you see this thing here, Thevenin's theorem, Norton's theorem, maximum power transfer theorem. So what you think now is the three theorems are अलग अलग या एक ही है? So what you fellows are thinking, you tell me now, is these three theorems are is अलग अलग theorems? आप सोचेगा क्या same theorems? What you are thinking? First of all, you tell me now, Thevenin's theorem, what will calculate? You tell me now. What we need to find? You tell me. We need to find the Thevenin's voltage VTH. Right. And thereafter, what we will find now here? RTH we should find. ठीक है. And the Norton's theorem, what we will find? You tell me now. Short circuit current. This is a Norton's current now here. The Norton's current, which we can also call it as what? Tell me now, short circuit current only. And what else you'll find now? This is Norton's resistance. That means what? Tell me now, RN. And maximum power transfer theorem, what you will do here? Tell me. Maximum power transfer theorem, so Pmax, maximum power we need to find. For that, so क्या चीज चाहिए हमको? You tell me. That is VTH is required. VTH is required, RTH is required. Agar, and what you will do here, tell me now, Pmax will find now, that is maximum power Pmax का formula बोलिए, that is VTH square by 4 RTH. Okay, VTH square by 4 RTH. अगर आपने ध्यान से देखा तो, so here you tell me now here, in this Thevenin's theorem, we require the two parameters we need to focus. Two parameters will get. And the Norton's theorem, how many parameters required? You tell me now, we'll get the two parameters. Okay. Now, maximum power transfer theorem. So here 2, and from this we'll get the VP max we can able to get. But लेकिन अगर आपने ध्यान से देखा तो, अगर if I know this VTH, RTH, if I know, can I get able to get the Norton's current? You tell me. Can we able to get the Norton's current? That is, so what is the RN is nothing but RTH only. First of all, you tell me. Thevenin's resistance, Norton's resistance, दोनों एक ही है ना? Equivalent resistance. And the ISC, that is short circuit current or Norton's current, which is nothing but what we can say, tell me now, VTH by RTH only. Other, if I know the VTH value and RTH value, then what happened, you tell me now? So Norton's current bhi milega. That means with this we can easily get the Norton's parameters, remember? And if we know the VTH, RTH, obviously P max will come or not? Maximum power bhi milega. Yeah, ध्यान से देखो इधर. Here you see this thing here carefully. So in this Thevenin's के लिए 2 parameters, Norton's के लिए 2 parameters, maximum power के लिए 2 parameters. अगर आपने ध्यान से देखा तो ये तीनों मिला के how many parameters required, you tell me? ये तीनों मिला के required parameters केवल 2 only, you see? All are same only ना? All are same. अगर आपको VTH, RTH मिला, we can able to get this IN value, RN value, and P max value will come up not? Isn't it? समझ में आया? Okay. So here, that is nothing but VTH by RTH only na? Okay. समझ में आया? You tell me now everybody. So अभी इसके बारे में हम अच्छा से डिस्कस करने वाले. सुनिए now with some examples and you will get to know the importance now. Yeah, take this problem, all of you. Take this problem and all of you do like the session and share to all your friends. All of you do like the session and share to all your friends. Do like the session and share to all your friends. Right now, take this problem here. Let's start doing this problem. Now you tell me now what you will do here to find the value of VTH and Thevenin's equivalent voltage. Let us find the VTH value, RTH value, ISC and maximum power. All will find in this problem. Okay? Yeah, tell me now here. What we should do here? Tell me. And so I can say this voltage, terminal voltage, and to understand I am giving the basic method VTH. Yeah, you tell me now here, this all are same nodes only now, tell me, which I can say this as VTH. Now, so we can write the nodal equations at this node, the same nodes now. Yeah, you tell me now here, nodal equations. So that is VTH minus 12 by 3 and minus 1 plus VTH by 6 equal to 0. right? Now you can tell me now here VTH we have taken common, then it is 1 by 3 plus 1 by 6, and which is equal to what will come here, 4 plus 1, that is 5 banega. So that means we have taken the LCM in the denominator. So 6 is a LCM. So it will be a 2 plus 1, and which is equal to 5. That means VTH value will come it as how much, you tell me now, 10 volts. And thereafter what will do, you tell me now, will find the RTH. And RTH के लिए what will do, you tell me now here, will redraw the circuit now here by deactivating the voltage and current sources. Now to redraw the circuit now here, voltage source is short circuited, current source is open circuited. Now do that one. And this is the voltage source, so which is shorted, and the current source is open circuited. Now we need to find the equivalent resistance between the terminals A and B we should find. So how much this resistance is? 3, and this is 6. And this is the RTH value, tell me. This is RTH. Yeah, you tell me now what is the RTH value, tell me now here. That is 3 parallel to 6. 3 parallel to 6, then which is given as what, tell me how much this value, tell me now, 2 ohms. Got it everybody? This is a regular method we used to do. VTH and RTH. Done. Now अभी मैंने आपको कुछ दूसरा मेथड के बारे में डिस्कस करने वाला. ये मेथड सीखने के लिए ट्राई करो. ये तो बहुत बहुत बढ़िया मेथड है. अगर आपको ये मेथड समझ में आया तो हियर यू कैन एबल टू सॉल्व एनी प्रॉब्लम. सो हमारा आज का सेशन में पूरा फोकस इज दैट ओनली. ठीक है. नाउ यू सी दिस थिंग हियर. और दूसरा मेथड क्या है, सुनिए ध्यान से. नाउ सबसे पहले हम रीड्रॉइंग द सर्क्यूट अगेन. redraw the circuit. Yes, यही तो आंसर है ना. सो द सेम थिंग वी आर गोइंग टू, तो कुछ अलग मेथड से करने वाला अभी. So this is 3 ohms, 12 volts. This is 1 ampere, and this is 6. या दूसरा मेथड क्या है, सुनिए. Now I want to find what, tell me now here, VTH RTH. अगर आपने ध्यान से देखा तो इधर ये जनरल मेथड, ये मेथड में हमने क्या किया, सो VTH के लिए अलग फाइंड आउट किया, RTH के लिए अलग फाइंड आउट किया. अभी हमारा मेथड में क्या होने वाला है, ये VTH RTH दोनों एक साथ मिलेगा. क्या है VTH RTH will come at a time, will come, दोनों एक साथ में मिलेगा. So सुनिए now how it can happen. Look at now here, this is a method we used to call this as a VTIT method. This is VT, this is IT. VT means what, will be now some, you can imagine that is a test voltage and test current. In the sense we can say voltmeter, this is like an experimental analysis we are doing. We'll connect on a voltmeter and we'll connect on a meter. Then from this we are going to analyze it. The voltmeter will measure the voltage, ammeter will measure the current, and इसके साथ resistance भी मिलेगा. सुनिए, look at now. Yes, obviously this is a parallel combination. How much is voltage? We can say terminal VT. Same thing. We can write the nodal same as what we did earlier. Same thing we can repeating again. Yeah, tell me now nodal analysis at this node. Yes, nodal analysis. Here this voltage is VT. VT minus 12 by 3 minus 1 plus VT by 6, and this is minus IT, which is equal to 0. Let's simplify this equation. So here VT I have taken common, then it is 1 by 3 plus 1 by 6, and which is equal to how much now here? 5 plus IT, isn't it? Tell me. 5 plus IT. Right. Oh, this equation not visible. I will write here. Is it visible now? Right. Now you can see now here. So now this is VT. LCM as usual same as earlier. LCM which is equal to 6. Now, so it will come to be what? Tell me now here. Now this is 2 plus 1, and which is equal to what? Tell me now. 5 plus IT. Five plus IT. All of you tell me. Now how much will come? You see this thing here, VT, which is equal to what? Tell me now. 1 by 2, and which is 5 plus IT. Now from this VT, which is equal to what? You tell me now. 10 plus 2 IT. 10 plus 2 IT. So now see this equation now here. So अगर आपने ध्यान से ऑब्जर्व किया तो here A equation देखो इधर. If you observe this equation, you see this thing here. Now इधर ये term है ना, उधर you can see now here this term. This is the VTH, and this coefficient of IT is there, that is RTH. Yeah, देखो. Yeah, tell me now here how much we got now from this method. से VTH कितना मिला हमको? 10 volts, and RTH value कितना मिला? You can see now here 2 ohms. Okay. अभी समझ में आया ये मेथड? The constant term है ना जो हुआ ना, that is a VTH, and coefficient of current IT, that is a RTH. This is the one method I want to discuss with you. ये तो बहुत बहुत बढ़िया मेथड है. So here अगर आपको ये डाउट आएगा, सर ये मेथड हमको पता है, दिस मेथड वी नो दिस थिंग, व्हाई टू लर्न दिस नया मेथड, ये डाउट आया होगा आपको, ठीक है. बट थिंग इज ये मेथड सो दिस इज द मेथड व्हाट यू लर्न. This method applicable if the network contains only independent sources. Remember, if the network contains only independent sources, the first method is valid. Okay, so this is a method 1. And the second method, what we have seen, this method is applicable if the network under independent source चलेगा, dependent source चलेगा, हर problem में चलेगा. Understood what I am saying here? If the network contain dependent source, independent source, one independent, one dependent, so हर केस में ये second method चलेगा. इसीलिए so we are focusing on this second method. समझ में आया? समझ में आया this thing? गेट सिलेबस एनफ फॉर ईएससी. गेट सिलेबस टेक्निकल तो फाइन, बट इसमें गेट ईएससी में नॉन टेक्निकल पार्ट भी है ना, वो पार्ट भी आप करना पड़ेगा. नॉन टेक्निकल पार्ट भी है ना, वो भी आप करना पड़ेगा. ठीक है, ये कॉन्सेप्ट आपको समझ में आया ना सभी को? बोल. डन. कैसा लगा ये मेथड आपको? बोलिए सभी ने. हाउ यू आर फीलिंग अबाउट दिस कॉन्सेप्ट? यू टेल मी नाउ ये मेथड. So here, but this method will be very much advantage if the network contain what will be dependent sources high. तो ये मेथड आपको बहुत अच्छा लगेगा. ठीक है, सो एक प्रॉब्लम लेके हम सॉल्व करेगा पहले to understand this thing here, and we'll take in this problem here. Take this problem. So Thevenin's equivalent we are going to find across this AB. I am taking this problem. You see this thing. Take this thing, and so here in this case, the network contain dependent source ना, so इसीलिए so the normal method नहीं चलेगा. So we should go for the VT-IT method only. We need to go. So here I need to find the VT across AB now. So I am connecting the VT-IT across A and B. So this is VT and this is IT. ठीक है, right? Now you can tell me now here. Yeah, so what we can do here? So this voltage VT. So I can simply write the nodal at this node. Now tell me at the VT node. Yes, you can tell me now here. So sum of entry current. So this current I1, which is entry current, 2I1 is also entry current. You can see now this is I1. This is 2I1 is also entry current, and this current is what? Tell me now IT. So tell me the equations now here. KCL equation I1 plus and 2I1 plus IT equal to what? Tell me now. 0. Now from this, what we can say now here? From this, that is 3I1, which is equal to minus IT. From this, I1 equal to what we can say? Minus 1 by 3 into IT. ठीक है. Now, so we'll see this thing. We should eliminate this I1 value now here. So in this case, what is I1 equal to from this now here? Current is flowing like this now. So where this I1, which is equal to what? Tell me now here. Yes, 0 minus minus plus minus VT by 4. So this is 8 minus VT by 4. Now this I1, I can equate these two I1s now. Tell me here. Equate the both I1s now here. That is 8 minus VT by 4 equal to what we can say? Minus 1 by 3 into IT. Okay. Bring this VT IT sa one form में लेकर आओ. So if we cross multiply here, this is 24 minus 3VT and which is equal to minus 4IT. Now this is 3VT and which is equal to what we can say now 24 plus 4IT, isn't it? Divide with 3 से divide किया तो then VT will come to be a what, tell me now here, 8 plus 4 by 3 into IT now, tell me. So see the equation now here. From this now we can say that what is the VTH and RTH value. Yeah, tell me now constant term. Constant term is what, tell me now, VTH na in this VTIT equation, constant term. And then here coefficient of this IT, which is RTH, and which is equal to how much now? 4 by 3. If we know this thing here, we can get this Norton's current will also will come now. So that is what, tell me now, VTH by RTH. So that is how much now here? 8 by 4 by 3. So we'll get cancelled. We'll come it as 3 into 2, 6. Yeah, you see this thing here. In this method में आपको VTH value and RTH value एक साथ मिला. देखिए बोथ VTH and RTH value we got at a time हमको मिला ना. ये तो बहुत बढ़िया है ना. अभी समझ में आया ये मेथड क्या इंपॉर्टेंस आपको? Yes. So, but in this may, so since the network contains dependent source, what happens, you know, we cannot do the basic method, nahi chalega. Deactivation of the sources not applicable. Independent source we can deactivate, but dependent source we cannot deactivate now. In that cases, we can use this method to find the values of RTH. Is this point clear to all of you? Tell me. Yes? Understood now? This is the beauty of this method. Yes. कैसा लगा ये मेथड? आप सभी को कमेंट करके बोलिए कैसा लगा ये मेथड आप सभी को. Done. So here, yeah, so and tomorrow also we'll meet in the same time. एंड सो और भी कुछ अच्छा प्रॉब्लम्स हम डिस्कस करने वाला कल. ठीक है, चलो, एंड विल मीट टुमारो सेम टाइम. एंड सो हियर वी आर गोइंग टू लर्न द सम न्यू प्रॉब्लम्स वी आर गोइंग टू सी. अगर किसी को डाउट हुआ तो ये प्रॉब्लम्स लेकर आओ बाय यूजिंग दिस वीटीआईटी मेथड. हर प्रॉब्लम यू आएगा. ठीक है.